Hey guys, we're going to build a simple still now. So for that we're going to need a round bottom flask of appropriate size, a three-way connector to be our still head. We're also going to need a thermometer adapter and thermometer. To that we're going to connect a West condenser, a vacuum adapter that's going to direct flow down into a 10 mil graduated cylinder, and of course we're going to have some connectors and a spin bar and some other clamps to keep things in place. So let's get started. In order to build our apparatus, we'll need a lab jack. We're also going to have a stir plate. Now that's also a hot plate, but we're only going to use it for stirring this time, and we're going to use a thermowell as our heat source. We want to be sure that thermowell is the appropriate size for the round bottom flask we intend to use. Be sure it fits snugly. And now we're ready to go. Let's get those electronics connected. We're going to plug our stir plate into the non-variable power outlet because we're going to use the dial on the stir plate to designate how fast that stirs. But our thermowell, on the other hand, we've got an external control for that. So let's plug that into the variable power outlet, the one that's got the variable power marking right next to it. Great, now we want to get that round bottom in place. So let's put a clamp on our rail using one of the knuckles that's available in your main lab drawer. Once that's in place, you're going to place, again, your appropriately sized round bottom flask in there. I recommend you sort of squeeze down on that two-finger clamp and then spin the wing nut. It's a lot easier to do this way instead of fighting against all that tension if you don't squeeze down on the clamp initially. And the next thing you want to do is get that plate and thermowell positioned directly beneath the round bottom flask so that it will heat it very nicely. Once I crank the lab jack up, you can see it fits very snugly and nicely. Next, we're going to attach our three-way adapter. For this, we need a gas-tight seal, so I'm going to apply just a pea-sized dollop of vacuum grease. We don't need any more than that, that's all it takes. We apply that to the male end of the ground glass joint and then insert it into the female end, giving it a twist to be sure that we get a nice clear ring all the way around. Once we have a clear ring around that joint, we know that we have a gas-tight seal. Next, I'm going to place a two-finger clamp on the adjacent rail. This is going to hold our flow director, which I'm going to place here, and try to approximate roughly where it would be if I were to put my condenser in between my still head and that newly placed flow director. Here I'm a bit high, so I'm going to bring it down. That's better. Now that it's there, I'll put a bit more grease on the male joint of the downward facing adapter from my three-way connector and on the downward facing portion of my condenser as well. And I'll place that and give it a little twist each time I add a new piece of glassware to be sure that I get a good gas-tight seal. There we go. Now I've clamped everything in place and that part of my build is complete. The next thing I want to do is place my thermometer so I can monitor the temperature in the still head. To do that, I will use my thermometer adapter, again with a dollop of vacuum grease, and then I'll place my thermometer through the rubber adapter on top, which is gas tight already, so there's no need for grease here. I'll push that down until the bulb of the thermometer is ever so slightly below the side arm where that vapor is going to move into the condenser. This is going to help me measure the boiling point of the distillate I collect. Next, I'm going to place a Keck clip, which has a large side and a small side, just like the glass joint does, right over that condenser. Notice that when I put the large side over the female and the small side over the male, I get a good snug connection. I'll do the same thing at the other end to be sure that that condenser stays in place because it's not clamped itself. Finally, I'm going to need a receiver, and for this I'm going to use a beaker to get some elevation, and I'm going to use a graduated cylinder to collect my distillate because it's so very important that I know exactly what the volume of distillate is that I've collected. Now I'm ready to apply my cooling water to my condenser. So I'll take a nice flexible water hose and attach that to the lower hose barb on my condenser. This is where the water will go in, so I'll place the other end of that hose over one of the water spigots in my fume hood. Of course, that water will need somewhere to go, so I'm going to place another hose on the upper hose barb, and that will run to the well sink in the back of the hood. Next, I'm going to turn on the water, being sure that I'm very careful about which one of the green knobs I'm turning so I know which water spigot I'm activating, and it will fill the tube from the bottom to the top. Now the jacket of my West condenser is completely filled with cold flowing water. Now it's time to load my sample, so I'm going to lower my heat source and I'm going to add my 50-50 mixture of ethanol and water to the boiling flask. I'm also going to add a spin bar so that I can agitate the mixture and be sure that I get even heating and avoid bumping in my still. Once that's reattached, I'm going to raise my heat source and my stir plate. And now it's time to run my still. I'll begin by activating the power to my fume hood, after which I will turn on my stir plate to a setting of about 200 to 300. This setting will give a nice steady stir and avoid bumping. So here is an example of one that is stirring at about 220. And not too bad. I think I'll take it. Next, I'm going to turn on my thermal well by activating the varostat and turning it to about 70 to 75. This should give me a nice even heating that will allow my still to run nicely. Before too long, a nice even boil should be observed if my stirring rate and my heating rate are appropriate. Next, I'll start to see a little bit of vapor condensing. If you look closely in the vertical part of the still head, you'll see that vapor condensing and rolling back into the boiling flask where it came from. But before too long, you'll start to notice that vapor also condensing in the side arm. And this is where it will condense, reach the cold area of my still, and then roll downward into the collection flask. If you watch carefully as this procedure continues, plotting the temperature in the still head as a function of the amount of distillate collected, you may notice that over time it slowly increases. This is because the temperature within the still head is essentially the boiling point of the distillate. And since I'm running a simple still, which is not capable of achieving a great separation, the composition of that distillate is slowly changing. After a significant period of time, you may actually notice that it eventually levels off. This is because all the ethanol has been removed and we're just distilling water at this point. So once we get to about half of the total volume that was added to the flask, we can get a few data points that show us that we have arrived at that point, and then we're ready to stop.